We just upgraded our primary LiDAR drone, and it immediately became unusable, not because it crashed, not because it failed, because of a battery swap. Let me explain. We're a survey and civil engineering firm with over 30 years in business. 8 years ago, we started integrating drones, beginning with a DJI Phantom 4 and expanding into a full fleet handling photogrammetry, 3D modeling, video production, and LiDAR. For the last 4.5 years, our LiDAR workhorse has been the DJI Matrice 300 RTK. And it still works perfectly. We're not replacing it because it's outdated. We're replacing it because we have bigger plans for it. So we upgraded to the DJI Matrice 400, and that's when the problem started. Our LiDAR payload is the Rock Robotic R3pro V2. On the M300, hot swapping batteries was seamless. It uses 2 batteries. During a swap, you replace one at a time while the other continues powering the drone and the sensor. The LiDAR never shuts down. The data stream continues uninterrupted. The M400 is different. It uses a single battery and relies on an internal capacitor to keep critical systems powered during hot swaps. What we discovered, the hard way, is that during a battery swap, power through the SkyPort adapter is reduced or cut off completely. When that happens, the R3pro shuts down. And when shut down improperly, the data becomes corrupted. For small properties, maybe that's manageable, but in land surveying, where large properties require multiple battery swaps, that makes the system unusable. So our brand new M400 sat grounded for over 2 months, not because it was broken, but because it couldn't do one of the most critical tasks our industry demands. There was no available solution, so we built one. The objective was straightforward in theory: mount an external battery to the drone and power the sensor directly, completely bypassing the drone's power during hot swaps. That way, when the M400 cuts SkyPort power, the sensor never knows it happened. It became obvious early on that a standard lithium-ion pack wasn't going to work. We needed high discharge capability, large capacity, stable voltage, and it had to be small and light enough to mount safely. After research and testing, we selected the Ugreen Nexode A power bank, an external laptop battery capable of delivering the sustained output we required. Using 3D design software, we engineered a custom battery housing mounted to the underside of the M400 and a custom mounting plate to integrate the Rock Universal adapter with the M400 SkyPort. The battery housing was printed in lightweight, durable plastic. The SkyPort mount was printed in carbon fiber reinforced filament to handle the dynamic loads created by the sensor in flight. Because LiDAR payloads aren't static, they create vibration, they create shifting forces, and failure isn't an option. As a final safety measure, we added 2 independent safety wires clipped to the SkyPort's metal frame, ensuring that even in a catastrophic failure scenario, the sensor would remain secured. This wasn't about making something that works. It was about making something that works safely. Before flight, we stress-tested the components, fitment checks, load simulations, destructive testing. Then came the test flight. We were confident in the mounting system, confident in the battery. But there were unknowns. How much flight time would we get? Would voltage differences affect the sensor? Would accuracy change? In our industry, accuracy is everything. If we lost precision, the system would be useless. The drone lifted off. The added weight from the battery system made no noticeable difference in flight characteristics: stable, predictable, normal. Then came the real test, the hot swap. Previously, this is where the sensor would shut down. This time, it didn't. After landing, we processed the data, and the results? Indistinguishable. Same accuracy, same precision, same reliability we've come to expect from the R3pro, just powered differently. The M400 wasn't ready for our LiDAR workflow, so we engineered it to be. Innovation in our industry isn't optional. Large properties still need to be mapped. Deadlines still exist. Accuracy still matters. The M400 is now operational in our LiDAR fleet. And the M300? it's not going anywhere. It has a new mission. And it might be the most exciting upgrade we've done yet.